Hello everyone, I Dr. Sanjay Obreti welcome you to the channel Electrical Science by Dr. Sanjay Obreti. So in today's video, we are going to discuss a question of a maximum power transfer theorem. So here, as you can see in this circuit, the question is you have find the maximum power that can be transferred to the RL in the circuit shown in figure. So the maximum power can be transferred to the RL for the certain value of the RL. So we have to find out that value of the RL for that value. The power transfer will be the maximum. So let us first find out what is the maximum power transfer statement of the maximum power transfer theorem. So this statement of the maximum power transfer theorem is maximum power transfer theorem states that the maximum power is transferred from a linear DC network to a variable resistive load when the load resistance equal to the Thevenin equal resistance or the internal resistance of the source. So if you have a one source here like this one, if you have a one source here, right, and if you have a connected a load resistance here, so load resistance, say this is the RL, this is the small r, which is the internal resistance of that source. This value is the V. So maximum power transfer will be transferred when the RL is equal to the small r, right? So this is the statement of the maximum power transfer theorem. But this circuit is having a multiple of number of the sources. So we will find out a similar circuit we will make an equivalent circuit which is similar to this a single source and with some internal resistance. So that is called the Thevenin resistance. So then when we are finding this equivalent resistance of equivalent circuit of this circuit, so then this value will become the VTH, value of this voltage become VTH, and this value of the internal resistance become the RTH. So when RL becomes equal to the RTH, so then the power transfer will be the maximum. So ultimately for this circuit, we have to find out the Thevenin equivalent of this circuit. So to find the Thevenin equivalent of the circuit, so what we will do, we will open circuit this value load resistance, and we will find the resistance between these two open point and the voltage between that point. So the voltage will be equal to the RTH, and voltage between these 2 points will become the VTH. So circuit will be like this one. If we open circuit this, if we open the load resistance, then, or let us mark this terminal as A and B. So value of the RAB, value of the resistance between A and B will be equal to the RTH, right? And similarly, voltage between the VAB will be equal to the VTH. So we have to find out the Thevenin equivalent. So RAB is equal to RTH when all the electrical source are made ineffective. To make them ineffective, so for Thevenin resistance, what we will do, we will make this 10 volts. We will short circuit that 10 volt source, and we will open circuit this. Current source. So objective of opening circuit of this 2 ampere source is that when you open circuit, when you remove this circuit here, when you remove this 2 ampere source by the 2 open circuit, then the current from here to here becomes 0. Right? Earlier the current was a 2 ampere, now the current will become 0. So that is why this 2 ampere current will become current source will become ineffective. Similarly, when you short this one, the voltage between here to here becomes 0. Earlier it was a 10 volt, so this 10 volt source become ineffective. So resulting circuit for the Thevenin resistance will be like this one. So this is replaced, current source is replaced by the 2 open terminals, and the voltage source is replaced by a short circuit. So resistance between the A and B, RAB, is equal to the, so that is 3 ohm resistance connected in series with the 2 and 5 ohm resistance, parallel combinations of the 2 and 5 resistance. So this is a very easily can be find out. RAB will be equal to the 3 plus 2 multiplied by 5 divided by 2 plus 5. So it is equal to the 3 plus 10 by 7, and it is can be written here as a 31 by 7. Simplifying this one, so this is RAB is equal to 31 by 7. Oh, right. So this one, so let me note here, that is the value of the, let me note here, it is RTH is equal to 31 by 7 ohm. And now we will find out the value of the VAB here. VAB here. Voltage between the A and B. So this voltage can be find out by many methods, but here we will be using the KCL method, Kirchhoff current law method. So let us assume this is a one node. This is a single one node. Let us say this node is X and voltage here is the Vx. So let us assume that the one current is leaving this node X here. This current leaving here is I1. Similarly, the current leaving this branch is I2. Similarly, current leaving in this branch is the I3, or current leaving this branch is I4, and I4 is 0 because this is an open circuit. So I4 will be equal to 0. So we will not consider this one. So applying the KCL, so KCL at the node X, right? So it will be means that the I1 plus I2 plus I3 is equal to 0. That means, so for the I1, value of the I1, here the potential here is the Vx, potential here is a 10, so I1 will become Vx minus 10 divided by 5. Okay, voltage divided by resistance, that is the current, or plus I2. I2 is here the 2 ampere is given, 2 ampere current source, and it is not leaving the node, but it is entering the node, so we will mark it as a negative. So it is plus minus 2 ampere, or plus I3. I3 will be Vx divided by 2. So Vx divided by 2, right? Here we have taken this this node as a that is connected to B. So VB here we have taken it as a reference node. The voltage here is the VB is equal to 0. It means that we are measuring all the voltages with respect to this node, right? So we can find out by from this equation. Let us multiply this equation by the 10. So it will become 2 Vx. When you multiply it by 10, so it will become 2 Vx minus 20, or that plus minus will become minus, and so minus 2 multiplied by 10, it will become minus 20. Similarly, Vx divided by 2 when multiplied by the 10, so it will become 5 Vx, or it should be equal to the 0. So here the 2 Vx and 5 Vx will become Vx is equal to 20, 20, 40. So value of the Vx is equal to 40 by 7 volt, right? So this value of the Vx here is the 40. This value of the Vx is the 40 by 7. Right? So value of the Va will be, because this 3 ohm resistance is open circuited. So whatever the voltage of the point X will be voltage of the point A will be the same as the point of X, because there is no current is flowing in this one. So here we can say VAB is equal to VA minus VB, or VA is equal to Vx. So it is Vx minus VB we have given as a 0. So value of the Vx equal to 40 by 7 volt. So this VAB is nothing but VTH. So the value of the VTH is equal to the 40 by 7. So we can write here the value, we can note down here. So Vx RTH we have find out the 31 by 7. Now we have find out the value of the VTH is equal to 40 by 7 volt. Now the Thevenin equivalent circuit, for this Thevenin equivalent circuit, we have find out both the values here. So, right. So this was the original circuit. Now this is a Thevenin equivalent circuit. The value of the Thevenin equivalent circuit, the VTH value we have find out the 40 by 7, or value of the RTH is equal to the 31 by 7 ohm. So what was the condition of this maximum power transfer theorem? So that the RL should be equal to the internal resistance of this voltage source. So internal resistance of Thevenin equivalent is 31 by 7. So for the maximum power RL is equal to the RTH, and RTH value is value of the RTH is 31 by 7 ohm. So that is the condition for this value of the condition for this maximum power value of the RL should be equal to the 31 by 7. So now this one is the Thevenin equivalent circuit. It is 40 by 7 voltage VTH is equal to 40 by 7, value of the RTH equal to 31 by 7, and value of the RL will be equal to the 31 by 7. So if the current flowing here is the IL here, so power L, maximum power of the PL, let me write this PL as a max, is equal to IL square multiplied by RL. So IL, value of the IL is equal to VTH divided by RTH plus RL square multiplied by RL. So value of the, let us put the value of the VTH. Value of the VTH is the 40 by 7, and divided by, that is RTH and RL both are similar, so it will become 31 by 7 plus 31 by 7, and the whole square of all this one multiplied by 31 by 7. So let us simplify this one. It will become 40 by 7, and if you add this one, so it will become 31 plus 31 is equal to 62. 62 divided by 7. So when divided, you can write divided by, this one is a 7 divided by 62, and whole square of this one multiplied by 31 by 7. So it will become, so it will get 7 will get with cancelled with the 7. So and it will divided by 2, it will become 20 divided by 31. So it will become 20 in the numerator, 31 in the denominator. So power, maximum power will be equal to the 20 multiplied by 20 divided by 31 multiplied by 31. This 31, that is the square, or multiplied by 31 by 7, right? So this 31 get cancelled with the 31, so it will become 400 divided by 217. 217. So P max is equal to 400 divided by 217 watt. So if you calculate this one, watt. So if you calculate this 400 divided by 217, so the value of this will become so value, when you calculate the value of this one, so it will be equal to the 1.84 watt. So that will be the maximum power that can be transferred to the load. So I hope you will like this video, and if you like, then hit the like button and subscribe to the channel. Thank you very much for watching this video.